Let's get right into it. In machine learning, the basic premise is that you provide a model with training data to predict a target variable, and then, with a little algorithmic magic, your model spits out its prediction. What you want is for your model to be able to then take in new data and make new predictions. However, you can, and will, run into many issues on your way. Two of the most common problems are underfitting and overfitting. Underfitting usually occurs when your model hasn't had enough time or data to train with, and, as a result, it cannot pick up on the general patterns needed to make accurate predictions. It can also be the result of a mismatched model, say, trying to fit a line to data that is in reality distributed along a quadratic. You can generally resolve this problem by picking a different model, increasing the amount of time or iterations the model trains for, or using more training data. While underfitting is quite straightforward, overfitting tends to be less intuitive. Overfitting essentially occurs when your model is too accurate. What this means in practice is that the model has learned patterns that are only in the training data, effectively using the random noise that arises in real-world samples to make predictions. This is obviously a problem because our new data will almost certainly not feature the patterns and noise our model uses, and, as a result, new predictions will be markedly less accurate. You can look for overfitting quite easily by comparing the error amounts between training data and validation data. Validation data being data you haven't used to train the model already. Here, you can see an example of the accuracy, mean absolute error, and mean squared error that might occur for an overfitting model. If you see that your results look highly accurate for your training data but terrible for your validation data, then you are looking at overfitting. To resolve overfitting, you will often need to graph out the accuracy of your model with different hyperparameters and see which ones produce the highest validation accuracy. Although, be forewarned that this can drastically increase the time it takes to train your model. Given that this is a very brief overview of these problems, I would encourage you to research the methods used to deal with underfitting and especially overfitting further, and better yet, put them into practice with an actual dataset. Well, that looks like all the time I have. Thanks for watching, and I wish you luck in your future data endeavors.